Welcome to this video in the rates 2 topic on the rate equation. And the objective from this video is that you would know the form of the rate equation for a general chemical reaction. So imagine that we've got this reaction here that's happening. We've got three reactants here. Reactants, and they're forming a single product. Let's call it P. Now the rate equation, sometimes known as a differential rate equation, is the following equation. Now we know that the rate of reaction here will likely depend on the concentration of the reactants, and so we can say that the rate of reaction is equal to some constant, a proportionality constant, times the concentration of A, the concentration of B, and the concentration of C. So we've essentially, what we've done here is separated out the rate of reaction into concentration dependent parts. So this is concentration dependence, and a concentration independent part, which is known as the rate constant. And the rate constant here is going to give us information about the activation energy of the reaction, and it depends on temperature. So it's a constant at constant temperature, a little bit like the equilibrium constant if you've come across that already. Now the concentration dependence is going to give us information about the reaction mechanism. And more on that in future videos. Now, in order to generalize this rate equation a little bit more, we need to understand that it's possible for chemical reactions not to just simply be directly proportional to the concentration of a reactant. And actually, a most general way to introduce that is to give each reactant an individual power. I'm going to call them little a, little b, and little c. And A, B, and C here are known as the orders of reaction with respect to A, B, and C respectively, and the sum of orders, so that's A plus B plus C, is the overall order of the reaction. And the idea of an order is essentially a way of just characterizing how strongly the rate of reaction depends on the concentration of a particular reactant that's involved. So notice it's only reactants here, not products. And depending on the order, that will determine how much the rate depends on that concentration. And the values we're going to be dealing with here, it could be 0, 0th order, 1, or 2. But you can have other orders, it's just we're confining ourselves in A-level chemistry to just these three orders of reaction. So that's the form of the rate equation. One final thing just to note about it is that the orders are not the same as the stoichiometric coefficients. So for example, in this reaction here, I wouldn't automatically say that lowercase a is equal to 1 just because there's a 1 here. So for example, A is not necessarily it might be, but doesn't necessarily have to be. So unlike the equilibrium constant, the rate equation orders cannot be worked out just from the stoichiometry of the overall equation. And that's why we need the study of kinetics in order to actually obtain these reaction orders and rate equations experimentally.